All right, today we're going to do a confidence interval for a two-sample proportion test. Remember last chapter we did a hypothesis test and a confidence interval for two different means? Okay, we had those crazy formulas and all that stuff. We're going to do the same thing today, except it's going to be for proportions. Okay. All right, so I asked you to take a look at this and come up with some p-hats for this. And this is actually what's going on today. I don't know if you guys are familiar with this, but Obama's putting forth an initiative to make preschool mandatory for all kids. Well, this is the kind of data they should be looking at. Is it really going to help them in these different subjects if they're in preschool? Okay. So, simple random sample, 142 students, 22 of them are still struggling with math. Monica, what'd you go with your p-hat?
Well, 22 over 142 is 15.5%.
Okay, did you label it? What'd you say?
I put p-hat 1.
I don't want that. All right, give me a letter that kind of says what's going on here. P-hat, what is this one? Getting a preschool?
W.
So sub P maybe?
Yeah.
Okay. Make it so something later on you'll be able to know what you're referring to. All right, you said 22 over 142, which is 0.1.
It's 1549.
Is that right?
Yeah.
1549?
Yeah.
Is it really?
Yeah.
So, we still have 15% of students, even though they went to preschool, we've got a little over 15% of the students from this sample that are struggling in math. All right, let's keep the same thing going. P-hat, what letter did you give us?
W.
Without.
W slash.
W? Without? What'd you want?
What? I did 2.
I know you would put 2. Give me another. I'm going to do C for control group. Whatever letter you got. All right, so here we've got 47 over 200, which is 0.235. Okay, so I can round this to 5. Is that okay? Okay, so what we want to do is compare this difference. So for our little problem here, how would you do the subtraction here? What would you want to do? It doesn't matter, there's no right or wrong, but how would you look at the subtraction if we were trying to find the difference of these two?
Control minus.
Because you want to work with a positive percentage? That's fine. But now we've got to know what that means, right? So you want to do control minus the preschool, which in this case would be the 0.235 minus 0.155, which is 8%. What does that mean? Okay, and now we're working with positive percentages, but you've got to understand what that means. That means that the preschools are helping 8% of the students in math, right? That's really what that means. Preschool students are doing, 8% of the students are doing better in math than the control group was. So however you do the subtraction, you've got to make sure you understand what that thing means. So here's our goal. We went out and did a good experiment, a good study. We found that the preschools were helping 8% of the kids, but that's just from our little sample. We want to now infer this onto the entire population. All kids who do preschool against all kids who don't. And will there be an improvement or not? So we're going to build a confidence interval around this 8%. Okay. I guess we're kind of hoping that 0 is not in that interval, right? If 0 is in that interval, then I'm not sure I'm getting any help at all. Okay, so today we're going to do the confidence interval part of this. All right, first off, we got another ugly formula. Go find it on page 5. It's not one you have to memorize. Just make sure you know where it is. Everybody see it? Now, what is this? Okay, well, we went out and did a big old sample. We took 142 students, we took 200 students, we found out how they were doing in math classes. We got a difference of 8%. Okay? Well, this represents the sampling distribution of every p hat c minus every p hat p. What if I went and took a different sample of 142 and 200? And I found that difference. That'd be another element here. So I go do the other one. Every single possible combination of 142 students and 200 students, follow them on, see how they're doing in math, find the difference. That's the sampling distribution we're analyzing. We got 8%. That was ours. Okay, among all the possible combinations that you could ever have. So what is this? Well, it's how spread out all those guys are. How spread out are they around the real population difference, whatever that is. Okay, so this is the formula that calculates how spread out our sampling distribution is. Okay. All right, let's go through the process. Much like we did with difference of means, except now we're using proportions. So let's start from the beginning. Population parameter, what are we going to put here?
True proportion.
Letter. Symbols.
Oh, P.
Yes. P sub. You want to do P first?
Huh?
P sub P first?
Yeah.
Okay. All right, give it to me. What's it? You don't have to write this down, but what would you write down? Yeah.
True proportion of students who had preschool, who struggled with math.
Yes. Okay, has everybody got that? It's the true proportion, the population. If I got all the kids in the world that went to preschool, what percentage of them will still be struggling in math? That's what you're defining right off the bat. Okay? Anything else?
Oh, you do P sub C.
Yeah. The true proportion of students who don't go to preschool that are still struggling in math. Okay, we can use ditto marks there if you want to. And then not a bad idea, although we're going to show it later, not a bad idea to just let them know how we're doing the subtraction. So the true proportion difference of control group minus the group that went to preschool that are still struggling. Okay. That's what we got from our sample. We got 8%. We're trying to predict what it would be for everybody. All right, let's go through the samples. Now, we're going to have to do our 2 checks again. All right, you need to identify which one is which. So, I don't know, let's say this one is the preschool group and this is the control group. Our first assumption, simple random sample. All right, now here's the deal. This type of problem we're doing, comparing 2 proportions, have to come from independently drawn samples. You remember last chapter when we were comparing the means and we had 2 samples but they were related? Remember we called that a matched pair and we did that a different way? And then we had the other type of problem that were independently drawn? Okay, there is no matched pair we're going to worry about here with proportions. Okay, we're only going to worry about the independently drawn ones. Okay, so what does that mean? Let's think about that. What that means in this problem. Well, I mean, I got all these students. Okay, they've all been to preschool. Hopefully I picked them out of a hat. Drew them. And then I got all these other students who didn't go to preschool. Those are totally independent groups, right? They're not the same person. Not going to be any match pair worries here. Then hopefully I picked all these out of a hat and studied them. Okay, so we need to make sure we have independently drawn. We'll take care of that on assumption 4. But on each one of these, you want to see how they drew the sample. I hope, for example, they didn't just go to one preschool and take all these students. Horrible sample, right? So you want to analyze that on both of these. Different situations, how they did the sample. All right, assumption 2. Got to check out to make sure that that particular formula works. If you want to just copy it off your page using the 1s and 2s, that's okay here. Remember, we're only making sure that this is the right formula to use. If you want to put the letters in already, you can, but you don't have to here. So, what is the standard deviation of all the p hat 1s minus p hat 2s? Square root p1, 1 minus p1 over n1 plus p2, 1 minus p2 over n2. And if you want to put in the p's and c's here, that's fine. That's okay. But remember, we just want to know if that's the right formula to use or not. In both of these, is the sample size less than 10% of the population? Is the sample size less than 10% of the population? You check them both. All right, here's where things get a little more interesting now. What's the third assumption we want to know? Is the sampling distribution of, and now the letters are important, p hat c minus p hat p normal. Okay, that's what I'm looking for. That's not what I'm looking for. I'm going to write this one down, guys, okay? Right, I'm not looking for normal sampling distribution, question mark. Okay, this thing's pretty complicated. So we're saying exactly what we're looking for here. All right, what is our formula that we have to look at? Well, it would be n, so this is n sub p, 1 minus, n sub p, p sub p, n sub p, 1 minus p sub p, both have to be greater than or equal to 10. And do we have a problem here?
It's not the population.
Yeah, I don't know that, do I? I have no idea what that is. So we got the same problem we had in that problem back here. So what's our solution going to be? We're going to use the p-hats, okay? And we'll go ahead and put that right in there, showing our reader that's the one we're going to have to use. So on this side, what is that? 142 times 0.155, whatever that equals. 142, actually I know what that equals, 22. And then 142 times 0.845, I know what that is too, 22 minus 120. Guys. Thank you very much. That checks out and we're fine. So you have to do that over here as well. This would be n sub c pc. N sub c p hat. Fine, the last one, we've got to make sure we've got good independent samples. We don't have some sort of weird match pair thing going on here. Okay. So I'll write 2 sample test. And then samples were independently drawn like we did last chapter. Samples were completely independent of each other. 2 samples were independently drawn. Okay, so it's pretty much what we've been doing before. Little changes in the sampling distribution. Okay, but this stuff is very much the same. All right, our test statistic. This is our formula to calculate our confidence interval. Here's our 8%. Okay, and this is going to be our margin of error formula. How many standard deviations do we have to go? And that's what a standard deviation is. So we got to plug in all the right letters here. So p sub c, p hat sub c minus p hat sub p, plus or minus z crit times, okay, get your right letters here. So this would be p sub c, 1 minus p sub c over n sub c plus p sub p, 1 minus p sub p over n sub p. And do we have a problem again? Right? This is the formula, but I don't know these again. So what are we going to do? We'll use the p-hat. Okay, so you can go ahead and put that in. All right, let's plug in the numbers. So how did we get our 8%? It was 0.235 minus 0.155. That's our 8%. That's the difference. We had an 8% improvement. Plus or minus, let's do a 95%. So 1.96. All right, got to get all these numbers in here right. So P sub C is 0.235 times 1 minus that, so 0.765 over that sample size, which is 200, plus 0.155, 0.845, all over 142. We know that's 8%. We've done that before. Now there's our challenge. Get that to work in your calculator. Give it a go. And use all the parentheses in the right place and that kind of stuff. Give it a try. Stop whining. Don't have to enter this, right? We're just entering this. We're just trying to find our margin of error here. I do it wrong about half the time. Did you guys come back in a minute?
Oh, yeah.
Thanks. Appreciate it. Go! Let's go! Get that thing to work in your calculator. I bet you can't do it. It should be on your paper right now. We're all doing the same one. You have to work.
Yeah.
That's probably wrong.
Alright. Probably is.
Alright, let me give it a try. 1.96 times the square root. I'm going to go one more parenthesis. Don't be doubting me. Times 0.765 divided by 200. I'm going to end that parenthesis. Plus parenthesis 0.155 times 0.845 divided by 142 parenthesis parenthesis. So you got to be careful, right? You got all those crazy parentheses in there and all that stuff.
I did.
So it turns out our confidence interval here is going to contain 0, isn't it? Is it okay to have a negative percentage? Let's think about the context of this problem. Do you ever actually think about it before you start shaking your head? Is it okay to have a negative percentage in this confidence interval? The answer is yes. Now, what would a negative percentage mean? It actually means the preschool kids are doing worse. You know what I'm saying? But it's okay. Sometimes a negative number is not okay, but in this case, a negative percentage makes sense. It just depends on how you do that subtraction. Let's fast forward. If we were doing a hypothesis test, which we'll be doing tomorrow, but would we be rejecting? No, right? 0's in that interval, right? So in our confidence interval, there being no difference at all between preschool and control is there. Same old conclusions we've had, except you got to be using the word difference now a bunch of times. Before taking my samples, 95% of the sample differences in proportion from the preschool group and control group would create a confidence interval that captures the true proportion difference in math between preschool and control. Our 95% confidence interval is. Yeah.
So if we, like, how are you talking about the whole, like, Obama's proposal to have every kid go to preschool? So
Based on this study,
it couldn't.
is it worth the money? Well, we don't have evidence that we don't have statistically significant evidence at a 95% confidence interval to say that it has a positive effect. Now, our sample did good, right? Our 8% in our sample, but can we infer that onto the population? Is that significant enough results based on that? No. Then some dishonest people might change that alpha level, right? Play with that, right? Don't want to do that. Okay, questions, comments?